For question 21, we're going to be asked these questions about this rational function. So what is the domain of the function? Well, this function exists everywhere except, remember, with rational functions, the one thing we can't have happen is we can't divide by 0. So what would cause division by 0? Well, when x plus 3 is equal to 0, we get division by 0, right? So we solve for this, subtract 3 from both sides, and we get that when x equals -3, the rational function becomes undefined. So our domain is everything else going to positive infinity from negative infinity. The only thing that we have to exclude is -3. So that is excluded, taken out of the domain. So the way we write that is we go from negative infinity to -3. We exclude -3. We're going to union that with the other side of -3. So notice this is a way to take -3 out of the domain, and then everything else is included. So that's our domain right here. And by putting it on the number line, it helps to see how things are going. What is the vertical intercept? Remember, a vertical intercept, that's a y-intercept. That's a value where x equals 0. So to get that, what we're going to do, let me change colors here. There we go. So we're going to take our function, x minus 2, we're going to plug in 0 for x. So we get 0 minus 2 over 0 plus 3. We're finding what is the function value when x equals 0. That is always the case with the vertical intercept. So that gives us -2/3. So the vertical intercept is, we sometimes can, depend on how they list it, it's y is -2/3, or it's the point 0, -2/3 as an ordered pair. Okay. So switch back to a different color here. So what are the zeros of this function? So that's a slightly different question. It's when is the y value equal to 0? And so we need to solve this. Notice we can't have the bottom being equal to 0, so actually we could just multiply both sides by x plus 3. X plus 3 divided by x plus 3 is 1. X plus 3 times 0 is still 0. So a shortcut is just to say, well, if it's going to be 0, it has to be the numerator that's 0. But if you don't remember that, go ahead and follow the full swoop. So we add 2 to both sides because we're solving for x. So 2 is equal to x. That is the 0 of the function, the x-intercepts. And again, there's only one of them. So we could list that as an ordered pair, 2, 0. So zeros have a y is 0. It's also called an x-intercept. It's also called a horizontal intercept. So you see what's going on there. Now the horizontal asymptote, we'll go with that one. Let me give myself some room here. So I'm going to clear all of this other stuff out. Horizontal asymptote, let's go up here. Horizontal asymptote occurs, there's 3 possibilities. One is, what we're going to review for the horizontal asymptote is just the largest degree in the numerator, which is just x, and the largest degree in the denominator, which is x. We get to ignore anything else, and so this is going to be like x over x in the long term. As x gets big, this is what happens. What's x over x? Well, that's just 1. 1 divided by 1 is 1. So our horizontal asymptote we're going to see is going to be y equals 1. So, as we're building this, we could kind of come up with the picture, right? We're going to get a horizontal asymptote at 1. We could put in our vertical intercepts and what's missing. We know that at -3, right? That is not in the domain. And that actually helps us answer this vertical asymptote. Vertical asymptotes occur for rational functions whenever the function's undefined, whenever the denominator equals 0. So notice when we answered the question about the domain, we solved this same equation, and we got that x equals -3 is not in the domain, but it is a vertical asymptote. So we're going to see something like that. So x equals -3 is a vertical asymptote. Then we're asked to compute the limit as x goes to infinity. So when x gets really, really big, what is that going to be? Well, that's that horizontal asymptote. This is going to go towards 1. The same thing happens when we go towards negative infinity. Again, negative over negative is still 1. So this also is going to go to 1, right? Because as we go to either of the infinities, what we're doing is we're getting closer and closer to that horizontal asymptote. And then we're asked to sketch the graph. And I've got a start here. What we'd have to do is what we came up with. What did we say? I shouldn't have erased everything. What are the zeros of the function? We have a 0 when x is 2. So that means we're going to cross right there. And we also came up with the vertical intercept. Put in zeros, it's going to be 0, -2/3. It'll be down here somewhere, right? So it looks like we're going to get something that comes up like this. And then over here, it'll follow these asymptotes and go this way. So that's what the graph would look like. We can also use our graphing calculator, or what I'll use is a online calculator because it's going to be easier. So I'll use Desmos. And I'm going to graph it. Let me enter it in here so you'll see it. It's f of x equals, move that on over. Let me clear this stuff out. And we had, we'll do x minus 2 divided by x plus 3. Oops, not that, that. And what we see is that we do have a horizontal asymptote at y equals 1. And I'm going to click on this, and it lets me put a little dotted line. So as we zoom out a little bit, we can see that's what's going to happen. That's the horizontal asymptote. We have a vertical asymptote when x equals -3. I'll change it also by click and hold on it. Come on, there we go. Can make it dashed, and let's also make it blue, just so those are not parts of the graph, but they're our asymptotes. And we can see here, this is -2/3, 6.6666 repeating. So that is our vertical intercept. Here is the zeros to 0. So we can also do this all with the graphing calculator, and it helps us understand what's going on. Okay, so your graphing calculator, do it all with the analytics.